Hey everyone, welcome back to the Deep Dive. Sometimes we cover some pretty out there stuff on this show, but today's topic is in a league of its own. We're talking about the Soviet Venera program and the conspiracy theory that claims they found evidence of, well, let's just say more than rocks in extreme temperatures on Venus.
Yeah, the Venera probes were pretty amazing feats of engineering, considering they landed on a planet where the surface is hot enough to melt lead. I mean, just surviving for any amount of time in that environment is an accomplishment. But then you add this whole other layer of speculation, this idea that they found something truly extraordinary, something the Soviets decided to keep under wraps.
Right, and that's what we're going to explore today, not to definitively prove or disprove the theory, but to really dive deep into it. What are the claims? What's considered evidence by those who believe it? And why do so many people find this theory so compelling, even in the face of what most scientists say?
It's a great question. And I think it starts with the core tenets of the theory itself. The idea that the Venera probes encountered, well, anomalies, let's say, is central to it.
Anomalies. Okay, so what kind of anomalies are we talking about? Like, did they find a rock formation shaped like a pyramid or something?
Well, some of the claims do focus on alleged structures or patterns in the images sent back from Venus, but it goes beyond that. We're talking potential signs of artificial structures, maybe even remnants of some past civilization, the suggestion of microbial life, though that's a tough one given the conditions, and even some theories point to unusual energy signatures that defy our current understanding of physics.
Whoa, hold on. Unusual energy signatures. That sounds pretty vague. What does that even mean in this context?
That's one of the things that makes this theory so intriguing and also so difficult to pin down. Proponents will often point to unexplained blips in the data, fluctuations in readings that don't seem to have a natural explanation, or phenomena that don't fit neatly into our models of Venus's atmosphere or geology. It makes you wonder if there could be processes, forces, types of energy that we haven't even conceived of yet, operating in such an extreme environment.
So it's not just about things they might have seen on the surface, but also things the instruments might have detected. Like, imagine finding a new form of energy.
Exactly. And then, of course, there are the images. A big part of the theory revolves around the idea that specific images and the data sets associated with them contain anomalies. This isn't usually about the quality of the early images. Those were pretty low res, understandably. It's more about how the images were processed, maybe unusual color palettes that some people believe indicate artificial manipulation, or patterns that look too deliberate to be natural formations. There's a real focus on the technical details of how these images were captured and transmitted, with proponents often questioning the official explanations.
So it's like people are becoming amateur image analysts, going through these decades-old photos with a fine-tooth comb, looking for clues that the Soviet scientists missed, or maybe even intentionally obscured.
Yeah, I think that's a good analogy. They're scrutinizing pixel by pixel, sometimes using modern software to enhance these images, trying to find shapes or textures that seem out of place. And this then naturally leads to the next question. Why would the Soviets, if they did find something significant, keep it a secret?
Right, the big question. Why the cover-up? What possible reasons could they have had?
There are a few theories about that. Some argue that during the Cold War, the Soviets were hyper-focused on controlling any narrative of scientific or technological superiority. They might have wanted to prevent the West from getting wind of any groundbreaking discoveries. Then there's the idea that the findings could have been so paradigm-shifting, challenging existing scientific theories about planetary formation or the possibility of life elsewhere, that they decided to suppress it to avoid upheaval within the scientific community. And of course, some even suggest potential military implications if they found evidence of advanced technology, even ancient technology. It really makes you think about how science, politics, and national pride can get tangled up, especially in that era.
It's a tangled web, for sure.
Yeah.
Okay, so we've got these potential discoveries, the alleged cover-up, but it doesn't stop there, right? There are all these other more anecdotal accounts that feed into the theory.
You're right. It's not just official reports and data analyses. The theory also draws on alleged cryptic statements from people involved in the Soviet space program, or even second-hand accounts, whispers from supposed insiders. These stories, while often lacking any hard proof, add to the mystery and the sense that something is being hidden. But with this kind of stuff, you always have to be careful, think critically about the source, their motives, and how stories can change over time.
Yeah, like a game of telephone, but with potentially huge implications. And speaking of information, let's go back to the data itself for a minute. It's not just the images, right? The Venera probes had all sorts of instruments collecting data.
Absolutely. The whole idea of anomalous readings and unexplained phenomena goes deep into the nitty-gritty of those measurements. We're talking about sudden temperature spikes or drops that don't make sense based on our current understanding of Venus, unusual atmospheric compositions with elements or isotopes and strange ratios, or weird radar signals that hint at subsurface structures we haven't officially mapped or acknowledged. Proponents of the theory will look at these readings and say, see, this doesn't fit the official narrative. There's something else going on here. And they explore both natural and potentially artificial explanations, questioning whether we truly have a complete picture of Venus's geology and atmospheric chemistry.
So I've got visual anomalies, unexplained blips in the data, and then this whole layer of secrecy and whispers. And the thing is, proponents don't see these as isolated incidents. It's about how all these pieces supposedly fit together, the signs and clues that point to a larger hidden truth.
Precisely. It's about connecting the dots, finding patterns in the alleged discrepancies, the inconsistencies they perceive in official reports, the gaps in mission timelines, maybe communication was lost for longer than admitted, or a probe changed course without explanation, this overall sense that there are unanswered questions, things the scientific community hasn't adequately addressed, and as we talked about earlier, the historical and political context of the Soviet Union, the secrecy that shrouded so much of what they did, that adds fuel to the fire.
Okay, we've laid out the framework, the core ideas of the theory. But what about the evidence itself? What are the specifics that people point to in the images, for example?
In the images, the focus is often on what are interpreted as geometric shapes. Proponents will highlight formations that look too regular, too symmetrical to be natural, like maybe they see a right angle where they'd expect more randomness. Then there are unusual textures that seem out of place in the expected Venusian landscape, like maybe a surface that looks too smooth or patterned. And, of course, there are the alleged anomalous light sources, bright spots, flashes, things that don't seem to be explainable by sunlight or atmospheric effects. A lot of this analysis involves using image enhancement software to bring out details that might not be obvious in the original lower resolution photos.
I get it. It's like looking for faces in the clouds, but with the added conviction that these shapes are deliberately constructed, that someone built them.
That's part of it for sure, the human brain's tendency to find patterns even where none exist. But those who believe the theory argue that the regularity and consistency of some of these shapes go beyond simple pareidolia.
Okay, so we've got the visuals. What about the data anomalies? How are those used to support the theory?
When it comes to the data, proponents will look for things like temperature readings that spike unexpectedly or stay unusually stable in areas where they shouldn't. They'll scrutinize the reports on atmospheric composition, maybe point to the presence of certain gases in quantities or ratios that are difficult to explain with our current understanding of Venus's chemistry. And then there's the radar data, which they'll examine for evidence of unusual surface features or subsurface anomalies, things that haven't been officially mapped or explained. Often, they'll compare data from different Venera missions, looking for repeating patterns, anomalies that pop up again and again, suggesting there might be a consistent underlying phenomenon at play.
It's like looking for deviations from the expected baseline, right? And suggesting those deviations point to something extraordinary. Now, what about those alleged whistleblower accounts? How are those factored into the theory?
Those accounts are often seen as key pieces of the puzzle. They're carefully analyzed for internal consistency. Do the different parts of the story line up? Does the narrative make sense? The motives of the person are also considered. Why would they risk coming forward? What do they stand to gain? And attempts are sometimes made to find corroborating details in other publicly available information, though that can be incredibly difficult given the nature of these accounts.
Right, it's not like there's usually a paper trail for this kind of thing.
Yeah.
A lot of weight seems to be placed on these often unverifiable personal stories.
Yeah.
What about those cryptic statements? How are those interpreted as evidence?
When it comes to those cryptic statements, a lot of contextual analysis is involved. People will look at the historical period, the specific language used, any known biases or beliefs of the person who said it. They'll try to decipher double meanings, hidden references, operating under the assumption that those involved couldn't speak openly about what they knew. And they'll compare these statements to other events or statements from the same period, looking for connections that might hint at a concealed truth.
It's like a historical puzzle, trying to piece together a hidden message from fragments. And finally, how do they interpret those perceived anomalies in the mission timelines?
With the mission timelines, they'll look for things like unexplained launch delays, sudden changes in a probe's trajectory that weren't officially explained, or extended periods of radio silence that seem unusual. They'll compare these to the timelines of other Soviet or international missions, suggesting that any deviations might point to unscheduled events related to the alleged discoveries, or maybe attempts to manage the flow of information coming out.
Okay, so we've got the theory, the supposed evidence, but we also have to acknowledge that these probes were operating in an insanely challenging environment. I mean, Venus is basically hell.
That's a good point. The extreme heat, the pressure, the corrosive atmosphere, all of that would have put incredible strain on the probes and their instruments. It's entirely possible that some of the anomalies people point to could be explained by the environment itself, by things malfunctioning or behaving unpredictably under those conditions. It's important to factor that in.
Right, so the environment itself could create what looks like evidence of something more. Okay, so now let's shift gears and look at the scientific perspective. How do scientists generally respond to these claims?
The scientific community has a very different take on this, unsurprisingly. They have a well-established, constantly evolving understanding of Venus, based on data from multiple missions over decades, not just the Venera program. They can explain Venus's current conditions using well-understood principles of physics and chemistry, and when specific claims of anomalies come up, they usually offer alternative explanations that fit within that scientific framework.
So, for every piece of evidence presented by the conspiracy theory, there's a corresponding scientific explanation.
Generally, yes. Like, with the alleged geometric shapes in the images, planetary geologists will point to natural geological processes that can create surprisingly regular formations, especially when you're looking at low-resolution images or dealing with image artifacts. Those unusual textures might be explained by specific types of volcanic rock or the way the harsh Venusian atmosphere weathers the surface, and those weird light sources could be sunlight reflections, atmospheric phenomena, or even technical glitches in the imaging systems. You also have to remember the limitations of the technology back then. The Venera probes were using 1970s technology, which wasn't nearly as sophisticated as what we have today.
Right, early space exploration was basically working with duct tape and a prayer, relatively speaking. What about those data anomalies?
For the data anomalies, scientists will offer technical explanations as well. Temperature fluctuations could be due to localized volcanic activity, which we know happens on Venus, or variations in atmospheric density. Strange atmospheric compositions could be the result of complex chemical reactions in that dense, hot atmosphere, or maybe outgassing from the planet's interior. And those odd radar signatures might just be previously unmapped geological features, or even interference with the radar signals. Science is all about refining our models based on new data, and what seemed inexplicable decades ago might have a perfectly reasonable explanation now.
It's like science is constantly updating its understanding. What about those alleged whistleblower accounts? How are those viewed from a scientific perspective?
Scientists are, by nature, skeptical, especially when it comes to anecdotal evidence without any solid proof. They'll look for inconsistencies in the accounts, logical flaws, lack of independent corroboration, and they'll consider the motivations of the person making the claims. Without hard evidence, these accounts just aren't considered reliable sources of scientific information.
It's about the burden of proof, right? Extraordinary claims require extraordinary evidence. What about those cryptic statements that conspiracy theorists love to analyze?
Historians and linguists are probably better equipped to analyze those statements than scientists. They focus on the historical and cultural context, the nuances of language, the potential for misinterpretations or quotes taken out of context. Often, a seemingly significant remark can be explained by the political climate of the time, common figures of speech, or just the limitations of language itself.
It's about understanding what the person really meant, in that moment, not reading too much into it. And finally, how do experts explain those perceived anomalies in the mission timelines?
When it comes to mission timelines, experts in space history and engineering can usually explain any apparent irregularities. Launch delays were common in the early days of space exploration due to technical challenges. Trajectory adjustments are just part of guiding a spacecraft. Periods of radio silence can happen when a probe goes behind a planet, experiences technical malfunctions, or is following a pre-planned communication schedule. It's all very grounded in the realities of operating spacecraft in deep space.
Makes sense. Okay, so we've explored the theory, the supposed evidence, and the scientific counterarguments. But I think it's also important to talk about why this kind of theory is so captivating to so many people. What are the psychological and sociological forces at play here?
I think it starts with that basic human desire to know if we're alone in the universe. The idea of extraterrestrial life is just inherently fascinating,
Hmm.
and conspiracy theories that suggest we've already made contact, but it's being covered up, tap right into that.
Right, it's like we crave that connection, that knowledge that we're not alone.
Exactly. And I think it also has to do with the appeal of the extraordinary, the human need for mystery. Conspiracy theories often offer a more exciting, more intriguing narrative than the often complex and less dramatic scientific explanations. We're drawn to the unusual, to the idea of uncovering hidden truths.
It's like we want to believe there's more to the story than what we're being told.
Absolutely. And then there's the issue of distrust in authority, in institutions. When people feel like governments or scientific organizations aren't being fully transparent, it creates fertile ground for conspiracy theories to take root.
We've seen that play out in so many different areas, not just with space exploration.
Yeah.
What about the influence of science fiction and pop culture?
Pop culture plays a huge role. Movies, books, TV shows, they often depict alien encounters, government cover-ups, secret societies, all of that. It normalizes these ideas, makes them seem more plausible in the real world. It gives people a framework for interpreting ambiguous information, and makes something like the Venera Venus conspiracy seem more believable.
Like, science fiction provides the templates for these real-world theories. And then, of course, there's the internet, which amplifies everything.
Oh, absolutely. The internet has been a game changer when it comes to how information and misinformation spreads. It allows unverified claims to go viral instantly, and it fosters online communities where people can reinforce each other's beliefs, often without any critical evaluation.
It's like these echo chambers where alternative narratives can flourish.
Yeah.
So what are the potential downsides to all of this? What are the risks associated with buying into a conspiracy theory like this one?
Well, one big concern is the erosion of scientific literacy and public trust in science. When conspiracy theories gain traction, they can undermine people's understanding of how science works and their faith in legitimate scientific findings.
And that can have real-world consequences, like affecting how people view issues like climate change or vaccinations.
Exactly. There's also the risk of distorting scientific data and historical records. Conspiracy theories often involve misrepresenting facts or cherry-picking evidence to fit a predetermined narrative, and that can hinder our ability to understand the world accurately.
It muddies the waters, makes it harder to separate fact from fiction.
Right. And then there's the possibility of wasted effort and resources. Investigating baseless claims can divert attention and funding away from legitimate areas of scientific research.
Like, we could be missing out on genuine discoveries because we're chasing shadows.
And lastly, it's important to acknowledge that conspiracy theories can sometimes lead to harmful narratives, to the spread of misinformation that can have negative social consequences.
So as we wrap up our deep dive into the Venera Venus conspiracy theory, it's clear that it's a fascinating example of how our desire to explore the challenges of scientific interpretation and the power of human imagination can all intertwine.
It really highlights the need to strike a balance between healthy skepticism and a sense of wonder about the unknown.
And ultimately, it underscores the importance of critical thinking. When we encounter extraordinary claims, we need to carefully evaluate the evidence, consider all possible explanations, and be aware of psychological and social factors that can shape our beliefs. We need to navigate the world with both a questioning mind and an appreciation for the vastness and mystery of the universe.
Well said. And that brings us to a final thought. Given the immensity of the cosmos and the limitations of our current knowledge, what other unexplained phenomena might we encounter in future explorations? And how should we approach those discoveries with the rigor of science, but also an openness to possibilities that might currently be beyond our comprehension? It's a question that speaks to the very heart of human curiosity and the ongoing quest for knowledge.
Thanks for joining us on this deep dive, everyone. Until next time, keep looking up and keep asking questions.